The drilling operations began in Russia in 1970 on a stretch of land located in the Kola Peninsula. This specific bit of Earth's crust is considered one of the oldest of the planet.
When Soviet drilling teams pierced deeper into the Earth than any human being had ever gone, they pulled something out of the darkness that should not have existed. Not at that depth, not at that temperature, not under that kind of pressure. And when the scientists who found it realized what they were looking at, the first instinct was not to celebrate, it was to hide it. This is the story of what they found, and why they were afraid to tell the world. Picture a laboratory in the far north of Russia. Spring of 1989. Outside, the tundra stretches to the horizon in every direction, flat and featureless and brutally cold. Snow still clings to the ground, even in May. The nearest city is hours away. Inside, a geologist named Viktor Orlov is hunched over a microscope. His hands are shaking, and not because of the temperature. A core sample sits on the table in front of him, a narrow cylinder of gray granite, hauled up from more than 12,000 meters below the surface just hours ago. Victor has examined thousands of these samples over his career. They are usually predictable. Granite is granite, dense, crystalline, monotonous. But this one is different. There is something caught in the mineral grain, something with structure, something with shape, something that looks unmistakably organic. He calls his colleague over. Nikolai Dashkov crosses the lab, leans into the eyepiece, and goes very still. For a long time, neither of them speaks, because what they are looking at changes everything they thought they knew about what lies beneath our feet. In the weeks and months that followed, the two men would argue, lose sleep, and question whether their instruments were lying to them. They would run the same tests over and over, hoping for a different result. They would not get one. The data was stubborn, the data was real, and the people in charge did not want anyone else to know about it. But to understand why that moment mattered, you have to go back to the beginning, to a race most people have never heard of, the race downward. By the late 1960s, the Cold War between the United States and the Soviet Union had produced a space race, a nuclear arms race, and an ideological battle that reached every corner of the planet. But there was another competition happening in parallel, one that history has mostly forgotten. A race not upward into space, but downward into the Earth. The Americans went first. In the early 1960s, a project called Mohole attempted to drill through the ocean floor off the coast of Mexico, punching through the crust to reach the mantle, the thick, semi-molten layer that makes up the bulk of the Earth's interior. The concept was audacious. The execution was a disaster. Budgets exploded. Political support evaporated. By 1966, Project Mohole was cancelled, having never come close to its target. Soviet scientists watched this failure very carefully, and they drew a simple conclusion. If the Americans could not do it, then perhaps the Soviets should. On May 24, 1970, on a desolate stretch of the Kola Peninsula near the Norwegian border, a team of Soviet engineers fired up a massive drilling rig called the Uralmash 4E and began to bore into the Earth. The Kola Peninsula was chosen deliberately. It sits on the Baltic Shield, one of the oldest and most geologically stable sections of continental crust on the planet. The rock here is ancient, some of it dating back billions of years, and it had been studied extensively. Soviet geologists were confident they knew what lay beneath this particular patch of tundra. They had seismic surveys, they had models, they had predictions. They were wrong about almost all of them. The project director was a tough, methodical engineer named Grigory Volkov. On the first morning of drilling, he stood in front of his crew and told them their target was 15,000 meters, nearly 10 miles straight down, deeper than any human being had ever drilled, deeper than most people can even conceptualize. If you took the highest point on Mount Everest and flipped it upside down, it would not reach the bottom of the hole they were trying to make. The early years were smooth. The drill chewed through granite at a steady, predictable pace. Core samples came up matching the textbook models almost exactly. Temperatures, densities, mineral compositions, everything lined up. The team passed 3,000 meters, then 5,000, then 7,000. Each milestone was reported to Moscow with pride, and each report came back with approval and more funding. Everything was going according to plan. And then the plan fell apart. The layer that vanished. Every geology student in the world learns about the Conrad discontinuity. It is a boundary inside the Earth's crust, typically found around 7,000 meters deep, where lighter granite is supposed to give way to a layer of denser basalt. For decades, seismic surveys had confirmed its existence everywhere scientists looked. The data was settled, the textbooks were printed, the matter was closed. So when the drill at Kola passed through the 7,000-meter mark in 1974, geophysicist Marina Petrova fully expected to see a clean transition in the core samples. Granite above, basalt below, simple, except the basalt never appeared. The drill kept going. 7,100 meters, 7,500, 8,000. Still granite, nothing but granite. The layer that every seismic model in existence said should be there simply was not there. Marina ran the analysis again and again. She checked depth readings. She cross-referenced instruments. She pulled older samples and re-examined them. The answer was always the same. There was no basalt layer. The Conrad discontinuity, one of the foundational features of geological science, did not exist at the Kola site. Now, here is what made this discovery so dangerous. For decades, geologists around the world had used seismic waves to map the interior of the Earth. When an earthquake occurs, the sound waves it generates travel through rock, and they change speed at boundaries between different materials. The sharp change in wave velocity at around 7,000 meters had been universally interpreted as the transition from granite to basalt. Thousands of geological surveys across the Soviet Union were built on this interpretation. But the Kola drill was providing direct physical evidence that the interpretation was wrong. The change in seismic velocity was real, but it was not caused by a change in rock type. It was caused by a change in the physical properties of the same rock under increasing pressure and temperature. The granite was still granite. It just behaved differently under extreme conditions. Marina brought her findings to the project director. Volkov read the report slowly, and his face went hard, because he understood immediately what this meant. If the seismic interpretation was wrong at Kola, it was potentially wrong everywhere. Decades of Soviet geological mapping could be compromised, and that was not merely a scientific embarrassment. In the Soviet Union, it was a political problem. He told her to keep it quiet. Not permanently, he said, just until they could be certain, just until he could consult with Moscow. Marina left his office knowing exactly what that meant. She had seen inconvenient data get shelved before. It rarely came back. Water in the abyss. The drilling continued, and the mysteries multiplied. In 1979, the Kola borehole surpassed every existing depth record on Earth. Government officials flew in from Moscow. Cameras clicked. Champagne was poured. The project was declared a triumph of Soviet engineering, and on the surface, it was. But beneath the celebrations, the scientific team was quietly struggling to make sense of what the drill was bringing up. In 1982, core samples from around 4,000 meters arrived at the surface wet, not damp from condensation or drilling fluid contamination. Genuinely, unmistakably wet. Liquid water was trapped inside microscopic fractures and fissures within solid granite, at a depth where every model said it could not possibly exist. The pressure at 4,000 meters should crush any open space. The temperature should drive off any moisture. There should be no room for water, no mechanism for water, and no explanation for water. And yet, there it was, slick on the surface of the rock, mineral-rich and ancient. Further analysis revealed something even more remarkable. This water had not been trapped during the rock's original formation. It had percolated down from the surface over millions of years, finding pathways through rock that scientists had confidently declared impermeable. It had seeped through cracks that were not supposed to exist, traveling deeper and deeper until the pressure was so great that it could go no further. And there it sat, sealed inside the crust, like a secret the Earth had been keeping for geological ages. The water appeared consistently in samples from between 3,000 and 6,000 meters. It was not a fluke. It was not a contamination error. It was a systematic feature of the deep crust that no one had predicted and no one could explain with existing models. Marina spent weeks running calculations, cross-referencing temperatures and pressures, trying to reconcile the data with established theory. She could not. The permeability models were simply wrong. The deep crust was not a sealed, impenetrable vault. It was porous, interconnected, and full of water that had been quietly migrating through it for longer than human civilization has existed. When Victor, then a young junior researcher, asked whether they would be allowed to publish the findings, Marina just looked at him. The expression on her face was all the answer he needed. Broken steel and stubborn men. In 1983, the drill crossed 12,000 meters, and the project paused for nearly a year. Officials toured the facility. Presentations were given. Findings were shared selectively. The missing basalt, the impossible water, the anomalous readings, none of that made it into the public presentations. What Moscow saw was a triumph. What the scientists knew was a puzzle. When drilling resumed in 1984, the Earth pushed back. At 12,266 meters, 5,000 meters of drill string, the long chain of connected steel pipes that carries the drill bit into the Earth twisted catastrophically and snapped. The broken section fell into the borehole, thousands of meters of steel tumbling into darkness, and it could not be retrieved. 3 years of careful, painstaking progress erased in a single violent moment. The sound alone was enough to stop every person on the rig. A deep, grinding shriek of metal tearing apart under forces that no engineering specification had anticipated. Then, silence. The kind of silence that falls when everyone in a room understands that something irreversible has just happened. Volkov stared at the readout for a long time. Then he told his team they would start again. A new branch, drilled sideways from 7,000 meters and angled back down. It would take years. He did not care. He was not the kind of man who stopped. The third attempt began in 1986. Slowly, meter by meter, the new branch pushed deeper. By 1989, they had reached 12,262 meters. It was the deepest point that any drill would ever reach at the Kola site, the deepest any human-made hole had ever gone. And it was at that exact depth that Viktor Orlov found the thing that was not supposed to be there. Life at the edge of the impossible. The core sample that arrived in Viktor's laboratory in May of 1989 did not look special. Another gray cylinder, another slab of deep granite. But under magnification, Viktor noticed structures embedded in the mineral matrix that were too regular to be geological, too organized, too deliberate. They had the unmistakable geometry of biology. He spent 3 days analyzing them, 3 days of checking and rechecking, using every tool available to him: optical microscopy, chemical analysis, comparison with known fossil databases. When he was certain, he called an emergency meeting of the entire research team. What he told them silenced the room. The core sample contained microscopic fossils, plankton, single-celled marine organisms preserved in exquisite detail, embedded in rock that was approximately 2 billion years old, found at a depth where the temperature exceeded 180 degrees Celsius, a temperature at which every published scientific model said organic material should be completely and irreversibly destroyed. And yet the fossils were perfect, intact, unmistakable. The implications were staggering. Either these ancient organisms had been carried to that depth by geological processes that somehow shielded them from the extreme heat and pressure for billions of years, or the conditions under which organic material can be preserved are radically different from what science believed. Either answer rewrites the textbooks. Either answer means the models were wrong. Marina pointed out the obvious objection. The thermal limits for organic preservation had been established through decades of laboratory experiments and field observations. This finding did not just challenge those limits, it demolished them. If life could be preserved at those depths and temperatures, it changed everything about how scientists understood the origins of life and the conditions under which biology can persist. His response was immediate and familiar: keep it internal. Do not discuss it outside this room, not until he had spoken with the ministry. Because this finding, like the missing basalt and the impossible water before it, contradicted published Soviet research. And contradicting published Soviet research was not a scientific matter. It was a career-ending one. Viktor understood the order. He also understood that following it meant the most important geological discovery of his career would sit in a locked filing cabinet while the rest of the world continued operating on flawed assumptions. The gas that shouldn't exist and the heat that broke everything. The fossils were not the last surprise the Kola borehole had in store. Not even close. Nikolai Dashkov had been studying the drilling mud, the thick fluid pumped into the hole to cool the bit and carry rock fragments to the surface. What he found in that mud was deeply unsettling. It was saturated with hydrogen gas, not trace amounts, not background levels. Enormous concentrations, far beyond anything the models predicted. When the mud reached the surface, it bubbled visibly, as though it were boiling, even though temperature was not the cause. No one could explain where the hydrogen was coming from. Either an unknown chemical process was generating it at depth, or it had been trapped in the rock for millions or even billions of years, and the drilling was releasing it. Either explanation meant the existing models of deep crustal chemistry were fundamentally incomplete, and either explanation opened doors to possibilities that no one had seriously considered before, that the deep Earth might harbor chemical processes entirely unknown to surface science. The hydrogen findings remained one of the most baffling observations of the entire project. The gas appeared at specific depth ranges, in concentrations that no geological theory could account for. To this day, the origin of that hydrogen is not fully understood. And then there was the heat. Before drilling began, scientists had carefully modeled the temperature gradient of the Earth's crust at the Kola site. Their calculations predicted that at 12,000 meters, the rock temperature should be approximately 100 degrees Celsius, maybe 110 at the outside. The models were considered reliable. They were based on decades of data. The actual readings came back at over 180 degrees, nearly double the prediction. The thermal gradient matched expectations down to about 3,000 meters. But beyond that point, the temperature climbed far more steeply than anyone had forecast. This was not just an academic problem. The extreme heat changed the physical behavior of the rock itself. At those temperatures and pressures, the granite stopped acting like a solid. Instead of fracturing cleanly under the drill, it deformed and flowed, wrapping around the bit like warm clay. The drilling team tried everything. Different bits, different speeds, different mud compositions. Nothing worked. The rock simply refused to break. If the Earth's crust was significantly hotter than predicted at these depths, it meant that thermal models used across every branch of geology, plate tectonics, geothermal energy, mineral formation, volcanic prediction, all of them needed to be fundamentally rethought. The temperature readings from Kola were not an anomaly. They were a warning that the planet's interior operates by rules we had not yet discovered. The silence falls. By 1990, the project was grinding to a halt. The plastic rock defeated every engineering solution the team could devise. A fourth branch was attempted in 1991, a fifth in 1994. Each one slammed into the same wall of superheated, flowing granite. The drill could not go deeper. The Earth had drawn a line. But by 1994, the heat was not the biggest problem. The Soviet Union had collapsed 3 years earlier. The new Russian government was hemorrhaging money, and funding for a deep drilling project with no commercial application was an easy target. The budget was slashed to nothing. Volkov gathered his team one final time. The project was over. 24 years of work, thousands of core samples, dozens of discoveries that the wider world had never been told about. All of it mothballed. Victor packed up his research materials slowly. He had arrived at Kola as an eager young geologist. He was leaving as a middle-aged man who had spent the best years of his career studying a planet that consistently refused to match its own description. They had never reached 15,000 meters. They had fallen nearly 3,000 meters short of the goal. For the scientists who had devoted their entire professional lives to the project, the closure was not just a budget decision, it was a kind of grief. They had built something extraordinary in the middle of nowhere, and now they were being told to walk away from it. Some of the team members had started as graduate students and were leaving with gray hair. They had raised families in the nearby settlement. Their children had grown up hearing stories about what was being pulled from the depths. And now, it was over. But what they found on the way down was worth more than any depth record. The site was abandoned. Buildings were boarded up. Equipment was left to rust in the Arctic wind. The borehole itself was sealed with a heavy industrial cap, bolted shut with oversized fasteners, 9 inches in diameter at the surface, over 12 kilometers deep. A needle of emptiness stabbing into the body of the planet, and now permanently capped. The truth surfaces. Years passed. The tundra crept back over the site. The buildings sagged and collapsed, but the data did not disappear. In 2007, Victor found himself in a conference room in Moscow with Marina, Nikolai, and a handful of other former Kola researchers. They had come together for a single purpose: to decide what to do with decades of suppressed findings. Marina did not mince words. Everything needed to be published. Every anomaly, every contradiction, every piece of data that had been locked away because it made Soviet geological doctrine look shaky. The missing basalt layer, the deep water, the ancient fossils, the impossible temperatures, the unexplained hydrogen, all of it. An older colleague, a man who had served in senior positions during the Soviet era, pushed back. There were reasons those findings had been kept quiet, he said. They contradicted accepted models. Publishing them had seemed reckless at the time. Victor's response was blunt. Science is supposed to contradict itself. That is the entire mechanism by which it advances. You observe something that does not fit. You revise your understanding. You build a better model. Hiding inconvenient data does not protect science. It cripples it. Marina laid out what had really happened over those decades. Researchers who made significant discoveries at Kola had been actively discouraged from sharing them. Some were told explicitly that publication was forbidden. When Nikolai had attempted to submit his hydrogen findings to an international journal in 1991, his security clearance was revoked for 6 months. He was called into an office and told that his work had national security implications and that further contact with foreign publications would result in permanent reassignment to a survey office in Siberia. The message had been clear. These discoveries stay inside Soviet borders. Over the following months, the former Kola team organized their data, translated their reports, and submitted papers to international journals. The initial reaction from the global scientific community was skepticism. The findings seemed too dramatic, too contradictory, too good to be true. But then other deep drilling projects started reporting the same kinds of anomalies. Germany's continental deep drilling program encountered unexpected temperatures and bizarre rock behavior at depth. Swedish drilling projects found unexplained gas concentrations. Austrian surveys discovered water at depths that were supposed to be dry. One by one, the Kola findings were confirmed. The models really were wrong. The Earth really was stranger, more complex, and more defiant of human prediction than anyone had imagined. What a group of Soviet scientists had discovered in isolation, under pressure to stay silent, turned out to be universally true. The Earth does not behave the way our theories say it should, and the only way to find that out is to go down there and look. A monument to humility. In 2010, a German geophysicist named Dr. Klaus Richter traveled to the abandoned Kola site. Victor went with him. They walked together through the ruins, rusting drilling towers, collapsed outbuildings, sheets of corrugated metal peeling away in the Arctic wind. Everything that had once been a center of extraordinary scientific ambition was now slowly being swallowed by the tundra. They stopped at the borehole cap, a heavy disc of steel, studded with oversized bolts, marking the top of the deepest hole ever made by human hands, 9 inches across, 12 kilometers down. Richter said something that stayed with Victor for the rest of his life. He said the remarkable thing about Kola was not the depth. The remarkable thing was that the team had drilled deeper than anyone and discovered that our understanding of the Earth was fundamentally incomplete. That was the real achievement, not the record. The record was just a number. The achievement was every moment when the data defied expectations and someone had the integrity to write it down instead of ignoring it. Victor looked down at the sealed cap and thought about all the core samples, the late nights, the arguments about data that refused to fit, the frustration of being told to stay quiet about findings that could have advanced global science by decades. Those moments of confusion and contradiction, he realized, had been the most important ones, the moments when certainty crumbled and the possibility of genuine discovery rose from the rubble. They never reached 15,000 meters. They fell short. But what they found on the way down rewrote the foundations of geology. Water where there should be none. Ancient life where it should not survive. A missing rock layer that textbooks swore would be there. Temperatures that shattered every prediction. Hydrogen gas that no one could explain. Each finding alone would have been a career-defining discovery. Together, they told a single, humbling story. We do not understand the planet we live on nearly as well as we think we do. Consider what these findings mean in practical terms. The deep water discovery changed how engineers assess geothermal energy potential. The temperature data forced revisions to models used in mining, construction, and resource extraction worldwide. The fossils opened new avenues of research into the origins of life and the conditions under which biological material can persist in extreme environments. Even the hydrogen gas is being revisited today by scientists exploring whether the deep Earth could be a source of natural hydrogen fuel. Every one of these practical applications traces back to a moment when a scientist at the Kola borehole looked at unexpected data and had the courage to say, "This does not match what we thought." That is the real legacy of the Kola super deep borehole. Not a depth record, a reminder. A reminder that the planet beneath our feet is far more complex, far more dynamic, and far stranger than any model or textbook can capture. A reminder that the greatest scientific achievements come not from confirming what we believe, but from discovering that we were wrong. And a reminder that the obstacles to knowledge are not always technical. Sometimes the biggest barrier to understanding the world is the simple human reluctance to admit that our best ideas were incomplete. Today, the Kola borehole remains sealed on that barren stretch of Arctic tundra. The buildings around it have collapsed. The equipment has rusted beyond recognition. But scientists still study the core samples that were pulled from that hole decades ago, extracting new data with instruments that did not exist when the samples first reached the surface. And somewhere, in laboratories and workshops across the world, engineers are developing new drilling technologies, new materials that can withstand extreme heat, new designs that can handle rock that flows like clay, new approaches that might, one day, allow us to push through the crust entirely and touch the mantle itself. When that day comes, and it will come, the drills will find more surprises, more anomalies, more data that forces us to tear up our models and start again. That is the nature of looking directly at the world instead of relying on theories about it. It is uncomfortable, it is humbling, and it is the only way science has ever actually advanced. The Kola Super Deep borehole did not give us the answers we wanted. It gave us something far more valuable. It gave us better questions. Questions about how water moves through rock we thought was sealed. Questions about how life persists in conditions we thought were lethal. Questions about what else might be down there, in the vast, hot, pressurized darkness that begins just a few miles beneath the ground you are standing on right now. The Earth keeps its own records, and those records do not care about human convenience. What do you think still lies hidden beneath the Earth's crust? Could we reach the mantle in our lifetime? And when we do, what surprises will be waiting? Drop your theories in the comments below. We read every single one. Thanks for watching. We'll see you in the next one.